For decades, the world believed fusion power was always almost ready, but never real. Then China did something that shook the energy world to its core. In a heavily guarded facility, engineers held a man-made star in place longer than any nation ever has before. While officials in the United States argue over budgets and timelines, China is moving fast, quietly turning theory into dominance. The race to be the world's most powerful energy source is on, and China may already be slipping away.
The energy bomb, China's artificial sun, shocks the world. At the end of 2024, something terrifying and historic happened behind closed doors in China. On December 30th, in a guarded research center in Hefei, Chinese scientists pushed a machine beyond limits the world believed were still decades away. The reactor is called EAST, short for Experimental Advanced Superconducting Tokamak. Many call it China's artificial sun. And that day, it did not fail. It did not flicker or collapse. Instead, it held a raging ball of plasma at 120 million degrees Celsius for 1,056 seconds. That is more than 17 full minutes. No country has ever come close. To understand why this shocked the world, you need to understand plasma. Plasma is superheated matter where atoms are ripped apart into charged particles. At these temperatures, it behaves like a violent storm. It twists, shakes, and tries to escape every second. Even a tiny mistake can end the reaction instantly. A small drop in magnetic control can cause the plasma to slam into the reactor walls and shut everything down. This is why past experiments lasted only seconds or a few minutes at best. China did not just beat the old record, it destroyed it. The previous best, set in 2023, was 403 seconds. EAST more than doubled that time. This was not luck, this was control, and that control scared a lot of people. Inside the reactor, every system had to work at once. Superconducting magnets wrapped around the machine created powerful magnetic fields to hold the plasma in mid-air so it never touched the walls. These magnets operate at temperatures close to absolute zero while holding something hotter than the sun. The walls themselves were lined with tungsten, one of the toughest metals known, chosen because it can survive extreme heat without melting or breaking apart. Heating the plasma required brute force precision. Engineers used neutral beam injection, which fires high-energy particles directly into the plasma to keep it hot and stable. Radio waves were also pumped in to maintain temperature and shape. All of this was guided by artificial intelligence systems that monitored the plasma in real time. These systems made thousands of decisions per second, adjusting power, shape, and pressure to stop the plasma from tearing itself apart. What makes this moment so disturbing is what it proves. Fusion energy works by smashing light atoms together, usually forms of hydrogen, to release massive energy. 1 kilogram of fusion fuel holds the energy potential of millions of kilograms of coal. It produces no carbon pollution and no long-lived nuclear waste. For decades, this promise was theoretical. EAST showed that continuous fusion conditions are no longer science fiction. This was not about producing electricity yet. EAST did not power cities, but it crossed a psychological line. Sustaining plasma for over 17 minutes proves that long-duration fusion is possible. That is the main barrier standing between experiments and real power plants. Experts immediately raised alarms. This is not just an energy breakthrough, it is a strategic one. A nation that masters fusion controls future energy supply, industrial power, and even military logistics. Fusion means freedom from oil imports, gas pipelines, and fuel shortages. It means dominance in a world that runs on electricity. While officials in the United States celebrate small, short-lived fusion wins, China just demonstrated endurance, control, and speed. And that is why this moment felt less like a scientific paper and more like a warning siren. Yet, this was only the opening move, because China is already scaling this success into a reactor designed not for records, but for power.
The monster reactor seeder and China's fusion empire. While the world was still trying to understand what happened inside the EAST reactor, China had already moved on to something far more disturbing. EAST was never meant to power cities. It was a test weapon, and the real threat is what comes next. Deep in Anhui province, China is building a machine that many experts quietly call the point of no return. It is named CEFEATER, the China Fusion Engineering Test Reactor. This is not an experiment designed to impress scientists, it is designed to dominate energy. Reactor is massive, the largest tokamak reactor in Asia, and in several key dimensions it rivals or surpasses ITER, the famous multinational fusion project in France that took decades just to coordinate. Reactor is not slowed by committees, foreign approvals, or political gridlock. It is built under direct state control, with one goal: make fusion work at scale before anyone else does. To understand how serious this is, look at what Reactor is designed to do. Most fusion reactors in the world are test machines. They study plasma behavior, heat control, and magnetic stability. But Reactor goes much further. It is designed to run continuously, not for minutes, but for long periods. It is meant to connect to the power grid. That means real electricity flowing to real cities. Even more shocking, it is designed to produce its own fuel. Fusion reactors need tritium, a rare and radioactive form of hydrogen. Tritium barely exists in nature and costs tens of millions of dollars per kilogram. While most countries depend on small external supplies, Reactor plans to solve this problem internally. Inside its walls, special lithium blankets will capture neutrons released during fusion reactions. These neutrons will hit lithium atoms and turn them into tritium. This means Reactor could feed itself. That means no imports, dependence, or limits. The scale of the reactor explains why this matters. The plasma inside Reactor will have a major radius of 7.2 meters and a minor radius of 2.2 meters. The cross-section reaches 4.4 meters. These numbers mean more space for hotter plasma, stronger reactions, and higher energy output. Bigger reactors are harder to control, but they are also closer to real power production. The project is divided into two brutal phases. Phase 1 aims to produce between 50 and 200 megawatts of fusion power with a Q factor between 1 and 5. The Q factor measures how much energy comes out compared to how much goes in. A Q of 1 means break even. Phase 2 is where fear sets in. China aims for over 1 gigawatt of thermal power with a Q factor above 10. That level can power a city, and it can do so continuously. What makes Reactor even more alarming is how it is built. Every major component is domestic. The superconducting magnets are built in China. The diverter, which handles extreme heat exhaust, is designed using Chinese supercomputers. Artificial intelligence systems monitor plasma behavior in real time and adjust conditions before instabilities turn into failures. This removes delays and dependence on foreign suppliers. This is where the global balance shifts. ITER relies on 35 countries. That means that delays are constant and costs explode. Reactor moves fast because it answers to one authority. That speed turns fusion into a strategic weapon. Energy is power. Control energy and you control industry, defense, and growth. Reactor is not just a reactor. It is a signal that China is not waiting to join a fusion future. It is trying to own it. And the implications go far beyond electricity, because fusion is now being tied directly to China's ambitions in space, military power, and global dominance.
Fusion versus fission, the clean energy revolution. The danger most people miss is this: the world is not just chasing better power, it is standing at the edge of an energy takeover. For decades, nuclear power meant one thing: fission. Heavy atoms split apart, releasing energy, radiation, and waste that stays deadly for thousands of years. Entire regions still fear old reactors because when fission goes wrong, it poisons land, water, and people. But fusion is different, and that difference is why this race is so terrifying. Fusion does not split atoms. It forces light atoms, mainly forms of hydrogen, to smash together and fuse into helium. When that happens, energy is released on a scale humans have never controlled before. 1 kilogram of fusion fuel can release the same energy as 10 million kilograms of coal. There is no smoke, no carbon dioxide, and no mountain of radioactive waste that must be guarded for centuries. The reaction stops instantly if conditions fail. That alone makes fusion feel unreal compared to everything that came before. But this clean promise hides a brutal technical nightmare. To make fusion work, hydrogen must be heated to more than 100 million degrees Celsius. That is hotter than the core of the sun. At that temperature, matter becomes plasma. Plasma is not solid, liquid, or gas. It is a violent cloud of charged particles that wants to tear itself apart. No material on Earth can touch it. If plasma touches a wall, the reaction dies in a split second. This is where China's progress becomes disturbing. To trap plasma, reactors like EAST and CFTR use superconducting magnets. These magnets create powerful magnetic fields that act like invisible walls. They force the plasma to float in the center of a donut-shaped chamber without touching anything. Superconducting means the magnets carry electricity with almost no loss, allowing stronger fields without massive energy waste. Heating the plasma is another fight. China uses neutral beam injection, which fires high-speed particles directly into the plasma to keep it hot. It also uses radio waves tuned to specific frequencies that make the plasma absorb energy from the inside. These systems must work together without failure. One mistake and the plasma collapses instantly. This is why artificial intelligence matters. Plasma is unstable by nature. It twists, ripples, and forms sudden disruptions that can destroy the reaction. AI systems now watch thousands of sensors in real time. They predict instabilities seconds before they happen and correct them automatically. Humans cannot react fast enough. Without AI, long-duration fusion would not exist. The reward for mastering this chaos is absolute energy control. Fusion can power entire cities without fuel ships, pipelines, or emissions. It can supply the massive electricity demand of artificial intelligence data centers that already strain power grids around the world. It can drive desalination plants, advanced factories, and military systems without depending on oil or gas. Fusion also changes space travel. Chemical rockets burn fuel fast and limit missions. Fusion-based power could support electric propulsion, long missions, and permanent bases on the Moon or Mars. Reliable energy in space means permanent presence, not temporary visits. This is why fusion is not just clean energy, it is a shift in global power. Countries that control fusion control growth, industry, and future technology. Fossil fuel exporters lose leverage. Energy importers gain independence overnight. China understands this. That is why it is pushing fusion as fast as possible. And that is why the gap with the United States is starting to look dangerous. But while China builds state-backed fusion giants, the US has chosen a very different path, and that choice may cost it the future.
The most shocking part of this race is not happening in secret labs. It is happening in plain sight, and most people are not paying attention. The United States likes to say it still leads in fusion, but this belief is starting to look like a deadly mistake. In 2022, the US celebrated a major moment at the National Ignition Facility, known as NIF. Scientists used powerful lasers to squeeze a tiny fuel pellet until fusion briefly happened. For a fraction of a second, more energy came out than went in. All major headlines called it a breakthrough. But what those headlines did not explain is this: the reaction lasted less than a blink. It did not produce electricity and could not run a power grid. It proved fusion was possible, not usable. China took a different path. Instead of short laser bursts, it focused on steady, long-lasting fusion using tokamaks. These are large machines that hold plasma in place using magnetic fields. While the US was celebrating a moment, China was building systems meant to run for hours and eventually non-stop. Money explains part of the shift. China now spends more than twice what the US spends on fusion research, and this funding is not scattered. It is directed by the state with clear goals and strict timelines. Entire cities, factories, and research centers are built around fusion programs. When China decides to scale, it scales without delay. The US relies heavily on private startups. Companies like Helion Energy and Commonwealth Fusion Systems promise fast progress and bold designs, but they live in a fragile world where funding depends on investors, rules change slowly, and permits take years. One delay can kill a project. This fragmented system cannot move at the speed China is moving. The supply chain gap makes the problem worse. Fusion machines need rare and precise parts. Superconducting magnets must be built perfectly to hold plasma in place. Power electronics must handle massive electrical loads without failure, and advanced materials must survive extreme heat and radiation. China controls most of these supply chains from start to finish. It mines the materials, processes them, and builds the components. The US often has to import or wait. This dependence creates a silent weakness. If supply lines tighten, progress slows, but China does not face this risk. It owns the pipeline. Experts inside the field are sounding alarms. Many now believe China could pass the US in fusion capability within 3 to 4 years. That means more patents, more trained engineers, and more working reactors. Once patents pile up, control becomes legal as well as technical. Latecomers must pay or fall behind. The stakes are far bigger than electricity. Fusion controls data centers that power artificial intelligence. It controls heavy industry that builds weapons and spacecraft. It controls space missions that need long-term power far from Earth. The nation that masters fusion sets the rules. This is not about pride, but about leverage. Energy has always shaped empires. Fusion removes fuel limits and emissions at the same time. Whoever controls it can dictate prices, access, and partnerships across the world. The US still has talent and history, but history does not win future wars. Speed does. Because China is not just building bigger machines, it is wiring intelligence into every layer of its fusion systems, and that may be the final advantage that breaks the race wide open.